they get home. Remember, if you're not signed up for Remind, that's huge. I always send out that link. Are you guys getting the videos, notes, assignments? Okay. Um, it's probably annoying to constantly get them if you don't need them, but when you do need them, at least you're getting them and you'll have it. All right. This first section 1.4, I will tell you, has a ton of vocabulary in it that we will use all year long. Stuff we learned here, we'll use second semester. It'll just come back and pop up in different places. And so it's super important that you understand this vocabulary in 1.4, okay? Starting with adjacent angles. Everybody with me in the notes where adjacent angles are? Okay. The definition for adjacent angles are two angles in the same plane with a common vertex and a common side, but no common interior points. So for example, if you look at this picture, angles 1 and 2 would be considered adjacent. When you think of adjacent, think of side by side, connected. Be careful though, if I draw this picture up here on the board, and let's say I have angle 1, angle 2, but then I have this big angle, angle ABC. Would angle ABC and angle 1 be considered adjacent? No, because, be careful, first of all, what is the vertex of angle ABC? B, what's the vertex of angle 1? B, so they do have a common vertex, and they do have a common side. What's the side that's in common between angle 1 and angle ABC? A is a point, a side of an angle is a ray, but you don't name it ray AB. How do you name it? A is not where it starts. BA. So remember, when you name a ray, you name it from its starting point, BA. So they do have a common side, but the part where it says no common interior points, that means if you have a point inside angle 1, it can't be inside angle ABC also if they're adjacent, but it is inside angle ABC. So those would be considered overlapping angles, right? Angle 1 and ABC, not adjacent. But if I pick a point inside angle 1, it is not inside angle 2. So 1 and 2 are adjacent. They have a common vertex and a common side. Okay, so they can't overlap and be adjacent. They have to be side by side. All right, sometimes your adjacent angles turn out to be a linear pair. A linear pair will always be adjacent. So a linear pair is made up of adjacent angles. They're always going to be adjacent, but they form a linear pair if they end up forming a line. A linear pair is just a pair of angles that form a line. If you look at angles 3 and 4, would you agree that they form a straight line? Okay, what should they add to equal then? 180 degrees, and they're going to expect you to notice that in the picture. If you see a linear pair of angles, then they are going to add to equal 180 degrees because they're going to form a straight line every time. Okay, and they may not tell you that. They may give you a problem like we learned last class period. They may say this is 2x plus 3, and this is 5x plus 6. And that means I can add them together and set them equal to 180, right? So that's a linear pair. They form a straight angle, a straight line. Hey, Jake, I left all your stuff there for you. Right where you left it. Are we good with linear pair? Okay, a linear pair has to form a line. They have to be adjacent. And that means that their non-common sides will end up being opposite rays because they're pointing in opposite directions. Okay? All right, so we're going to look at some examples here together and see how you're doing. We're going to tell whether the angles are just adjacent and they form a linear pair, or they're not adjacent at all. So let's start with this one, AEB. So look at that angle, and BED. Would those be adjacent and form a linear pair, or not adjacent at all? Adjacent and form a linear pair. They have a common vertex, they have a common side, and their non-common sides form opposite rays or form a straight line. Okay, but we're not talking about C right now. We're just looking at these two angles. So if it helps you, you can redraw them. AEB in the picture. And then the next angle they said to look at was BED. So if it helps you, redraw them and separate the stuff that you don't even need in the picture. Are those two angles adjacent? Yes, they have a common vertex, a common side. And do they form a straight line? Yes, they do. So they are adjacent and they form a linear pair. Okay, point C is just a point in between that angle, but there are infinitely many points in between an angle. Just because they chose to label this point C and put a ray in it doesn't affect the fact that this big angle BED is adjacent to AEB. Does that make sense? Okay. Make sure your homework's in the tray, okay? And if you want to, Ridley, you could jot down 5 minutes and 57 seconds on your paper if it helps you, and then you could watch this first part if you need to when you get home. Okay, let's look at the next one. AEB and BEC. You guys look at it on your own, decide if you think they're adjacent and a linear pair, or not adjacent at all. If it helps, redraw them. What do we think? Adjacent. AEB is referring to this angle. BEC is this angle. They do have a common vertex. They do have a common side. They're not overlapping, but they don't form a straight line, right? If we just look at those two angles, then we're not including this part, and those two angles do not form a straight line. So it would just be adjacent. Okay, DEC and AEB. So your answer should either be adjacent and form a linear pair, or not adjacent at all. What do you think? Not adjacent. If you draw them, DEC is referring to this angle right here. And if you look at AEB, that's this angle right here. A lot of people want to say, oh, it's a linear pair, but they're not adjacent angles. And to be a linear pair, they have to be adjacent. They're not adjacent because they don't have a common side. Notice the red and the blue lines don't lay on top of each other. There is the space in the middle that is not accounted for. So this angle and this angle will not add to be 180. You would also need this angle in it to add with it. Does that make sense? So to be a linear pair, they have to be adjacent and they have to be a straight line. So this one would be not adjacent. Any questions on that idea? Okay, super huge. The next two words you guys should have learned before back in middle school at some point, complementary and supplementary. And I want to emphasize too, what does pair mean? Two. So I'm going to go back to linear pair for just a second. A linear pair is a pair of angles that form a line. If it takes more than two to form the line, it's not a linear pair. Okay? Complementary and supplementary also are going to be two angles. Two angles. So these are pairs of angles, okay? If it takes more than two, then we don't call them complementary, we don't call them supplementary. Complementary are two angles who sum to 90 degrees. They do not have to be adjacent. Any two angles that add to be 90 will be complementary. So for example, if you look at this picture, which two angles here would add to be 90? A and B. Notice they're not adjacent. They're not connected. They don't have to be. But A and B would be complementary. They could be connected. You could have a picture like this, where I have angle 1 and angle 2. What does this little box right here mean? 90 degrees. So do angles 1 and 2 add to be 90 degrees? Yes. So this would be a picture of two angles that are complementary but are also adjacent. Okay? Hey, welcome, girls. Pause for just a second. If you guys want to jot down on the notes on your desk, we're going to be at about 10 minutes into the video. So if you want to go home and watch that first 10 minutes, You'll kind of know where to pick up at. And make sure your homework's in the tray for me. Gotcha. Hey, welcome, Sarah. So you'll want to watch probably the first 10 minutes of the video. And then if you're home, get your homework out and put it in the tray for me, okay? I'm going to give our girls just a minute to get organized, get their homework turned in, get their notes out. So if you guys will just chill for just a second and wait on them. That's right. Always chill. That's good. All right, and while they're getting ready, how about a joke of the day? You ready? Okay, joke of the day. What do you call people who are in favor of tractors?
Farmers.
Say it again. Say it, Brianna. Protractors. There's your geometry joke of the day. Let's see if the next one's funny at all. No, that's not funny. But it's really bad. Okay. All right. You asked for it. So the teacher says, today we are going to learn about complementary angles. And the student says, does that mean the angles are nice to each other? Told you it was bad. Tristan, have a good day. Okay. Are we about settled, girls? Cindy, you about ready? Okay. Oh my God. Okay. Elena, you good? All right. So did I get all of your homework? Elena, Cindy? Homework? Sarah, you got your homework in here? Okay. All right. So picking up, if you guys will turn in your notes in section 1-4, I'm not sure what, we're on the back maybe of the first page or so. So complementary means they have to add to be 90, but they do not have to be adjacent. A linear pair has to be adjacent and it forms a straight line. Supplementary means that they're going to add to be 180. So if they add to be 180 and they're adjacent, we call them a linear pair. But if they just add to be 180 and they're not adjacent, like what two angles here would add to be 180? Like A and C, then we would just say they're supplementary. Does that make sense? If they were connected so that I had a 53-degree angle and it was adjacent to a 127-degree angle, they would be supplementary, they would be adjacent, but we would more specifically call them a linear pair because they're forming a straight line. Does that make sense? So if they ask you on the homework to identify, you want to identify it with the most precise name. So these would just be supplementary, but these would be a linear pair. Okay. Now, this becomes the harder part, and the questions on the test that I typically see students miss. So pay close attention. You can find the complement of an angle. There's a difference between complement and complementary. Okay, complementary means two angles that add to be 90. The complement is just one of those angles. So for example, I'm going to start off real simple. If I have a 30-degree angle, what is its complement? 60. If I have a 50-degree angle, what is its complement? 40. Okay, so complementary means two angles that add to be what? 90. Complement is going to be one of those two angles. So if I have a 20-degree angle, what is the 20-degree angle's complement? 70. So it's the value that adds to it to make it 90, right? But that's a bad definition for complement because it will not help you when you get to the word problems. So the better definition is the complement of something is going to be, and I'm going to change this to 90 minus the angle, because using the variable x might confuse you on the homework. So 90 minus the angle. So once again, if I have a 25-degree angle, what is its complement? Very good, 65. 90 minus 25. So supplement, same idea. Supplementary means two angles that add to be what? 180. But the supplement is just one of them. So if I have a 100-degree angle, what's its supplement? 80. Are we getting the idea? Better definition, though, is 180 minus the angle. And I'm going to say that because I think it'll help you when you get to the word problem and you see the word complement or supplement, you can plug into that spot either 90 minus the angle or 180 minus the angle. And then it'll make the word problem a little easier. So we're going to look at some simple ones and then we'll get to some harder ones. Find the measure of each of the following. The complement of f. We just did this. What's the complement of f if f is 59 degrees? 31. So it should be 90 minus 59. Don't forget your degree symbol. Okay, notice on part B, though, our angle is not just a numerical value, it's an algebraic expression, right? That means when you give me your answer is probably still going to be an algebraic expression, and that's okay, just simplify it. So if I want the supplement of G, supplement means 180 minus the angle. What am I going to plug in for the angle? 7x plus 10. And notice I put it in parentheses. You will get this wrong if you're not careful. You're not just subtracting 7x, you're subtracting the whole thing, 7x plus 10. So what do you need to do with that negative? Distribute it. So this becomes 180 minus 7x minus 10. And where students will make a mistake is they'll put plus 10. So be careful, you're subtracting the whole angle. Then simplify. What can we simplify here? So 180 and negative 10 becomes what? 170 minus 7x. Is there anything else we could combine or simplify? No, and so that is your answer for the supplement, because it's just an expression. Unless you have an equation, there's nothing you can solve. Does that make sense? So your homework might have expressions as answers, not just a numerical value.
Does it matter if the 7x is different?
It does not, as long as you keep the negative with it. So it should be negative 7x plus 170. But no, it won't matter.
Can you tell the difference?
I won't count off for that, but I do because that's good notation to show that it is an angle measure in degrees. The book will always put it like that too. Because if I were to write this equation down, let me see if this is what you're saying, Alexis. So you're saying this angle, G, which is 7x plus 10, plus the missing angle, its supplement, should equal 180, right? But this angle doesn't equal 180. It's not a straight angle. And if I do it this way, then I have to call this other missing angle something, and I can't call it x because x is already being used. I could call it y, but then I would still have a variable. I would have two variables in one equation. And in Algebra 1, we learned there's no way to solve two variables with one equation. You need two equations.
Why can't you set it equal to 0?
The angle equal to 0?
Yeah.
Because angles have to be a value greater than 0 or you don't have an angle at all. Okay? So we don't know what this angle is equal to. We just know that whatever it is plus its supplement together should be 180. And so we're just trying to come up with an expression for the supplement that if I were to add those two together, so now that I have it written down, 170 minus 7x plus 7x plus 10, this should come out to be 180, right? And it does, right? These cancel. It's negative 7 plus 7. And 170 plus 10 is 180. So, yay, we're getting somewhere. Any questions now? Okay, they're going to get harder. Let's look at some more. So here's an example that will be very similar to your test. So I'm going to warn you, definitely this is on your test. Very important that the ones that are on your homework that are similar to this, practice them, know how to do them. And while everybody's in here now, let me just say, guys, you've got to use me. If you were at home, homework should not take you 3 hours to do your homework. If you're struggling and you know you're staring at it, you're stressed out, you're struggling, text me. I promise you, and here's the other thing, several students this weekend texted me. When they texted, I would send back not, here's how you work the problem, but have you done this, have you tried this, what have you written down? If you get that message and you read it and you go, I have no idea, that did not help me at all, then text back, I'm still lost, I don't get it. I'm going to keep helping you. I just don't want to work it for you because that doesn't do you any good. What will help you is if I can get you started, like draw a picture, now label this, do you see anything now? And we can just keep going back and forth until the light bulb goes off and you're like, oh, I got it, this is easy. But you have to use me. I'm going to challenge you in here. It's going to be hard, it's going to be fast-paced. I am going to grade your homework. I'm going to make you work really hard to earn your grade, but I'm going to be there for you. So you have to use me. Call me, text me. Don't hesitate, and don't spend forever and then turn your homework in not finished, because that's only going to come back to hurt you. I promise. The hardest ones on the homework, if you skip the hardest ones on 1-1 and the hardest ones on 1-2 and then 1-3 and then 1-4 and then 1-5, before you know it, you've skipped a lot of problems. And then you get to the test. What if all of those problems are on the test? Then you're in trouble, right? So don't do that. Okay, so if you did that this time, don't do that next time. Call or text me. All right. So here, there are a lot of ways you can work this problem, okay? Let's read it first, and then I'm going to show you one way I would work it from the algebra teacher in me, and then you may come up with a geometry picture or a different way that you like it better. So it says an angle is 10 degrees more than 3 times the measure of its complement. Find the measure of the complement. It's kind of wordy, right? So what I would do in algebra, if I had a word problem, is I would break it down word by word, plug in numbers and symbols to represent the words. So an angle, do we know what the angle is? No. What do we use in algebra when we don't know what something is? A variable, x, any variable you want. So I'm going to put x for an angle, because I don't know what it is. Is, what do we use in math if we say that an angle is this? Equals, equals. So x is equals 10 degrees more than. So what does that mean we're going to do if it's going to be 10 degrees more than something? Add 10. Not times. Times would be multiply, but 10 degrees more than means we're going to add 10 to something. Okay, so 10 degrees more than means let's add 10. And it's 10 degrees more than 3 times the measure of its complement. So times means we're going to do what? Multiply. So we're going to add 10 to something, and that something is 3 times. So when I have it in parentheses, that means I'm going to multiply, right? 3 times what? The complement. Go back to your definition for complement. What did I tell you to use for the definition for complement? Oops. 90 minus the angle. Okay? So complement should be 90 minus the angle. So when you see that word complement in your word problem, always write down 90 minus and then whatever you've called your angle. So the complement should be 90 minus, and what did we call the angle? X. Okay, this is one way you could work it. We'll look at another way in a minute. Is everybody following me here? Is equals, more than we're going to add, less than what would we do? Subtract, times means to multiply, and if you don't know what something is, call it a variable. If you see complement, you're going to put 90 minus x. If you see supplement, you're going to put 180 minus x, or whatever you've called your angle. Okay, so now we can do our algebra and we can solve, but keep in mind, what does x stand for? The angle. What are they asking me to find? The complement. So when I find x, that's not my answer. I've got to go back and subtract it from 90. Okay, so let's solve it. What do I need to do first here? Distribute. So x equals 3 times 90 is 270. 3 times negative x is negative 3x plus 10. Okay, can I combine like terms on the right? 270 and 10 is 280. So I have x equals 280 minus 3x. From there, add 3x to the other side. So now we have 4x equals 280. Divide by 4, and what is x? How many times does 4 go into 28? 7. So it is 70. Okay? But again, that's not our answer because that's the angle. We want the complement. So our answer would be what? 90 minus 70, which is 20 degrees. Okay, here's another way you could do it. If this helps you, you could think about it in terms of a picture. I've got two angles and they have to add to be 90. So I'm going to draw a picture. Ooh, that's terrible. Draw a picture. I know they have to add to be 90. One angle is 10 degrees more than 3 times the measure of the other one. So one angle is 10 degrees more than 3 times the measure of the other one. So I'm going to call the other one x. 3 times x plus 10. Are you with me here? 10 degrees more than 3 times the measure of the complement, the other one. Okay? And then we could use our angle addition postulate. X plus 3x plus 10 should equal 90. Now we get 4x plus 10 equals 90. Subtract 10. 4x equals 80. And divide by 4 and we get x is 20. And that's our answer because we called what we were looking for the complement x. So one angle is 3 times more than, or 10 more than, 3 times the other angle, which is the complement. So this was the complement in our picture. How many people prefer the algebra way? How many people prefer this picture way? Okay. And it's up to you. It doesn't matter to me. Just be really careful that you are reading it and breaking it down and getting your expressions correctly. Guaranteed you will have some questions like that on your test, okay? All right, you and your partner, see if you can answer this question by looking at the picture. Okay, here we go. Let's check and see how you did. So it says lights passing through a fiber optic cable reflects off the walls of the cable in such a way that one's congruent to 2. Right now, you should be able to tell me what the measure of angle 2 is. Okay, if 1 is 47 and 1's congruent to 2, then that means 2 is 47 degrees. That one should have been really easy, right? Okay, go to the picture. This is 47 degrees angle 2. This is 47 degrees angle 1. It tells you that angles 1 and 3 are complementary. So if 1 is 47, what does 3 have to be so that they're complementary? 43, so that they add to be 90. And if 2 and 4 are complementary, then 4 has to be 43 degrees also. And this, you probably won't remember by the time we get there, but maybe you will. This is an example of a theorem we're going to learn later on that you're going to need to know and use in proofs. It's called the congruent complements theorem. Basically what it says is when you have 2 angles that turn out to be complementary to 2 other angles that are congruent, then that means these 2 angles are going to end up being the same or congruent. Okay? So we'll talk more about that theorem when we get there, but here is an example where they kind of lead up to that just in a picture. Okay, the last thing that's in this section, 1-4 notes. Oops, and I've clicked it too many times. Give it a chance. I try to go too fast and then I mess it up. Be patient. This is not in your notes because I didn't think you needed it. What you will notice is when you look at the filled-in notes that I send out at the end of the day, those have all kinds of examples and all the details, not just what's in your notes. So there's even extra examples in there if you need them. And then the video is just what we went over. Okay, last thing that's in your notes is vertical angles. These are huge. Again, linear pair, complementary, supplementary, and vertical angles we will use all year long. And again, you should have heard of a lot of these things already before. Vertical angles are 2 non-adjacent angles. They are not going to be adjacent. They will share a common vertex, but they won't have a common side. They are non-adjacent and they are formed by 2 intersecting lines. So when you look at this picture, you have 2 intersecting lines. There are 2 pairs of vertical angles here. Angles 1 and 3 are vertical. Angles 2 and 4 are vertical. Vertical angles are basically the angles that are across from each other when 2 lines intersect. Does that make sense? Okay, I'm going to teach you your very first theorem today. There's a difference between a postulate and a theorem. Postulates, we said the definition was we accept them as true without proof. We believe them, they're kind of common sense. Theorems are proven true. There are proofs that will back up every single theorem that we learn. Sometimes we'll do the proof, sometimes we won't. Most of the time we won't because of time. But we'll learn the theorem. So you're going to add to your notes our very first theorem. It's not in your notes. I don't know why they didn't put it in this section because they expect you to use it in this section. But they put it later in the book. So I'm going to go ahead and give it to you now. It is called the vertical angle theorem. And there's something that I forgot to tell you on day 1. And you're probably not going to like it, but I'm going to tell you now. In pre-AP geometry, if you have not heard, I count off for spelling. Yes. So, here's the deal. I don't count off until I have reminded you several times. So, typically, there's some things that I count off for on the homework all the time. I count off. If it's wrong, it's going to be counted off. There are some things on the homework that I'll remind you about on the homework, but I don't count off for it. And then when we get to the test, if you have not learned from your mistakes on the homework, it's going to count off on the test. So if you've gotten your homework back already and you notice that I corrected your spelling or corrected your grammar, I'm going to do that to make you better students because education's not just about math. Especially since you're in pre-AP, I'm expecting you to be a little higher level and rise above. I also know, though, when you get to pre-AP Algebra 2, Mrs. Siegert is going to be even more strict when she grades the writing parts of things. You should be starting with a capital letter. You should end your sentence with punctuation. It should make sense. Your grammar should be correct. So I'm going to be marking those things on your homework to help you, but I will definitely count off for spelling, okay? One of the most misspelled words is vertical. So that's what made me think of it. I forgot to tell you day one. So vertical is not C-L-E, which is what a lot of students write. It's vertical, C-A-L, okay? Vertical. C-L-E is what a lot of people do, but vertical, okay? So I use things like that. That's how I remember how to spell stuff. But be careful, because on the test, every time that you misspell something, that's minus a half. Chapter 1 test, yes. Okay? But I've been correcting you as I've been grading your homework, so few of you I know for sure should have some things on your homework back. Okay, so vertical angle theorem, here it is. This is what it says. Write it down. Vertical angles, and by the way, this is how you can abbreviate angles. I should also mention that you are not allowed to abbreviate words in here at all unless there's a symbol that we've learned. If we've learned a symbol for it, you can use the symbol. So equals, congruent, angles. When we learn symbols, you can use those symbols. So vertical angles, this is just an angle apostrophe S. The book does this. And a lot of times that confuses students. That just means angles. Okay? So vertical angles are congruent. That's the theorem. Vertical angles are congruent. You need to memorize the name, vertical angle theorem, because you're going to have to use it later in proofs. But all it says is that two angles that are vertical are congruent to each other. So 1 and 3 are congruent, 2 and 4 are congruent. So again, makes it a lot of times it's things you can look at and go, oh, duh. And that's what makes proofs hard, is because when you get to a proof, you're like, of course it's true. But you've got to get a detailed explanation down. And so that's the hard part. Any questions on this? Okay, so that should be the end of your 1-4 notes, right? Okay. Oh, on the back. Yes, sorry, vertical angles. This one, thank you. So name the pairs of vertical angles. Look at the picture here with me. I need one person to name 2 angles that are vertical. Be careful, to name an angle, you have to have 3 letters. Remember naming angles. Okay, I heard KMH. First of all, KMH is a straight line, so it would not be an angle. That would be vertical. I heard HML, so we'll start with that one. Angle HML, what is it vertical to? JM what? K, so angle JMK. So it says list the pairs of vertical angles. Pairs means 2. So here's 1 pair of vertical angles. There should be another pair in the picture. Sorry, one more time. Angle LMK, and that is going to be vertical to angle HMJ. So now we're talking about these 2 angles. So make sure you're using correct notation on how you name things. To name angles, you have to use your angle symbol. 3 letters if there's more than 1 angle in the picture. And obviously we have more than 1 angle in this picture, so we have to use 3 letters. All right, any questions on 1-4? Basically, it's just a bunch of vocabulary. Linear pair, complementary, supplementary, vertical, and adjacent. Big ideas for 1-4. 1-5 is going to take you back. Right now, turn your 1-5 notes face down where you can't see them. Everybody, turn them face down. Don't look at 1-5. Everybody with me? Okay, I'm going to see what you remember before we start 1-5. Okay, so 1-5 is going to be talking about perimeter and area. So, first question for you is, what is perimeter? Okay, so the distance around an object. What do we call that if that object is a circle instead of a rectangle or square? Circumference. And the reason we call it circumference is because the definition for perimeter is not really the distance around. The definition for perimeter is the sum of all the sides. And a circle doesn't have any sides. So they give it a separate word. They call it the circumference. What is the area? The space inside, or the number of square units inside your object. Keep in mind, area is going to be units squared, like feet squared, inches squared. Perimeter and circumference will just be inches and feet. All right? Let's think about some formulas you might have learned before and see what you know. So if I have a triangle, to find the perimeter, I'm just going to add all the sides, right? Oops. A plus B plus C. There's nothing special about that. Do you remember the area formula for a triangle? Very good. 1/2 base times height. Now let's be real careful with base and height. Any side of your triangle can be your base. Base does not mean bottom. It can be the bottom. If this is my base, then my height has to be perpendicular to my base. So this would be my height, right? Okay. But if I had called this my base, then my height would have to go from this vertex over here perpendicular. And I could turn my triangle if I wanted my base on the bottom. Does that make sense? Are you with me? Okay. But the formula you need is 1/2 base times height, right? All right. Good. You guys remember that? Let's go to a square. What's special about a square versus a rectangle? All sides are the same. So I could call this S, 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 S. They're all the same, right? What kind of angles do squares have? Right angles. They're all 90 degrees. Okay, so if I wanted to find the perimeter, instead of doing S plus S plus S plus S, what could I do? 4 times S. Perimeter. Area, how would I find the area of a square? S times S. And what is S times S? S squared. Because we're just doing base times height again, or not 1/2, but base times height, and that would just be S times S, which is S squared. Okay, rectangles. They're different. They still have right angles, but they don't have 4 equal sides. So I'm going to call this the length and this the width. What would my perimeter be then for a rectangle? Okay, so first of all, get your head that you're thinking perimeter. We're adding all the sides. Now, what did you guys say? 2L plus 2Ws, because we're going to have an L up here and a W over here, right? Okay, so we could do L plus W plus L plus W, but it's much easier just to do 2L plus 2W. How do we find the area of a square? Length times width. They may call this the base and the height, and then you would just do base times height. Length and width, base and height, those words can be interchangeable. Are we good so far? You guys remember this? Okay. So they'll have to give you the height in the picture. Keep in mind that your height could be outside your triangle if you have an obtuse triangle. So if this is my base, my height would go from this vertex to this base, but it's got to be perpendicular. So sometimes your heights are outside your triangle, right? Do you guys remember seeing pictures like this? Okay, so we're going to have problems like this in section 1.5, but this is basic information. They're going to throw algebra in it to make it more complicated. Okay, but that's the big idea for 1.5. So flip your notes over. Ignore this. Okay, so we're going to just quickly go through the things you just told me, okay? And that way if you're highlighting or writing things down, you can refer back to it here. Perimeter, remember you said distance around, but I said it's really the sum of the side lengths. Okay, it is the distance around, and that's fine to think of it that way, but the reason why you need the word circumference is because circles don't have sides. So it's the sum of the side lengths. Area is going to be the number of non-overlapping square units that cover the figure. The number of non-overlapping square units that cover your figure. Again, I want to emphasize area is going to be units squared, whereas perimeter is just units. In putting your units, I will be super picky about that. So make sure in all your answers you have your units if they've given you units. Okay? One thing I forgot before we go any further, one shape I didn't put up here was the circle. Do you guys remember the circumference formula for a circle? Mm-hmm. 2 pi r is one option for circle. Thank you. There's also another way you can write circumference. Uh-huh. Not 1/2. Just pi times diameter. Okay, think about why. Yes, because your radius is half of your diameter. Are you with me? A radius goes from the center to the side. So it takes 2 radii to be 1 diameter. So you can have 2 radii is equal to 1 diameter. So if you have 2 radii here, that's the same as 1 diameter. Okay, so 2 pi r or pi d, those are both circumference formulas. How do you find the area of a circle? Doesn't have 1/2. Say it again. One more time. No 2, just pi r squared. There's only 1 2 in each of the formulas. Either it's circumference and it's 2 pi r, or it's area and it's pi r squared. And again, it's because your units are squared. Think about it that way. Your radius is squared in area. Okay, so those are also in here. This slide shows exactly what we wrote over here in green. Okay, those are the formulas. You will have to memorize your formulas before your test next Monday. So if you don't know your formulas right now, those and the circle, which will come up in a little bit. Okay, your big chapter test will be next Monday. And so on the test, you'll have to know what formula to use based on your picture. Now, I would warn you, if it's a perimeter question and you can't remember 2L plus 2W, just don't forget that perimeter is to add all the sides. So just add all the sides, okay? So don't get too hung up on that. Okay, base and height. I mentioned this already just a second ago when I was talking about how base can be any side. What did I just do? Lashley, come on. There we go. So the base can be any side of a triangle. What matters is where the height is. So if you have a picture like this, again, and you decide you're calling this side the base, then your height has to go from the opposite vertex perpendicular, meaning that it's forming a right angle to your base. So you can pick any side to be your base, but then your height has to be drawn perpendicular to it. Okay? Can you draw it on the outside? If this picture, like this, or in a different one? So if you have an obtuse triangle, you could call this your base, but if you do, then your height ends up being outside your triangle so that it is perpendicular to the line that contains your base. Or you could let this be your base, and then your height would be inside your triangle if you went from this vertex over perpendicular. So it just depends on what information do you know in the picture as to what side you want to use and what height you're going to use. So then again, the definition for height is it is a segment that goes from a vertex that forms a right angle with the base or with the line that contains the base. Your height has to form a right angle with your base. It may be that it's outside your triangle, so it's with the line that connects to your base, like in the picture, but it still has to form a right angle with your base. And then here's some examples in the picture that you can see where your height's inside and outside your triangle. Okay, and I already said this. Perimeter is linear units, like inches. Oh, now it's not going to write. And then area is expressed in square units, like centimeters squared. I didn't even do anything. Why does it do that? I know. I don't know. Okay, let's see if it lets me write. I don't know. Okay, you guys with me though as far as, yeah, why though? I don't know what's going on. I don't know. I'm touching something and I don't know what I'm touching that's causing it to happen. I don't know. It's something somewhere, I just don't know. Oh well, I don't need to write on it. I'll write on the board like I've been doing. So I want you guys to try this example really quickly. It should be super simple. Biggest mistake students make on the homework is they don't read their directions. Just get the answers. It's your notes right now. Okay? What do the directions tell you to find here? Perimeter and area. Make sure you're reading all of your directions because sometimes students only answer the first part of the question and then that's points you just missed. So this one should be pretty easy since it's just numbers, right? What shape is in the picture? A rectangle. So if you're doing all the formulas showing all your work, which you may need to do as it gets a little harder, the perimeter for a rectangle is 2 length plus 2 width. The length in the picture is either 6 or 4. It's really not going to matter. Plus the width would be then the other one. And so you should have ended up with 12 plus 8 or a perimeter of 20. And what am I missing? Inches. So make sure you put 20 inches is equal to your perimeter. And make sure you identify whether your answer is for the perimeter or the area. Okay, area formula is length times width, which means you have 6 times 4. My chemistry teachers will encourage me to include my units in my work in geometry because then when you get to chemistry, how many of you are in chemistry this year? How many of you are in physical science? Okay, the rest everybody's in biology. So when you get into chemistry, you're going to be dealing with units a lot. So I won't count off in here if you don't do this, but they will tell you if you'll include your units, it'll make everything make more sense. 6 times 4 gives me 24, and inches times inches is inches squared. And then that'll help you remember that your units should be squared, okay, because you're multiplying the inches. Does that make sense? Okay, any questions on the first one? Real simple math. Okay, obviously they're not going to keep it easy on you. So now we're going to look at some problems where there are expressions. Same directions, find the perimeter and the area. So let's do this one together. How do I find the perimeter of a triangle? All the sides added together. So I'm going to have x plus 4 plus 6 plus 5x. Okay, stop right now. Does it tell you to solve for x? No. So that just means you're going to have a variable in your answer, and that's okay. If they gave you variables in the problem, more than likely you're going to end up with variables in your answer. Just like when we were doing complementary and supplementary, and we had variables in our problem, we had variables in our answer. Now, I could make this problem really hard, and I'm not going to. But could we solve for x? What would we need to use? 90's angles. Those are the sides. We would use the fact that it is a right triangle. What did we do the other day for bell work when we had a right triangle? Good. We could do Pythagorean theorem and actually solve for x here. It would be a lot harder and require a lot more algebra, but it didn't tell me to solve for x. So I am not asking you to do that, okay? Just find the perimeter, and that just means leave your answers completely simplified. So we can simplify this. What would our perimeter be simplified? 6x plus 10. Units, did they give me any units in the picture? No. Here's my rule on units. If they don't give you units, you don't have to put units. You can write the word units if it makes you happy to put that there. But you can't write the word units if it gives you specific units. If you write 20 units, I'm going to count off because you didn't put inches. Okay? So if they don't give you units, you don't have to put them. You can just leave it off. Okay? But if they give you units, you have to put them. All right, area. What's our formula for area of a triangle? 1/2 base times height. What's going to go in for our base in our picture? 6 is the easiest side to use because then what's the height? X plus 4. Remember, your base and your height have to form a right angle. So 6 and x plus 4 form a right angle. Okay, then you can multiply and divide from left to right using your order of operations. So what's half of 6? 3. And then we're going to multiply 3 times x plus 4. So what do we do there? We distribute. And so we get 3x plus 12. Can we simplify it any further? No. Circle it, and that's your answer. This is not squared, so be really, really careful. I see this every year. I'll see students who do this, 3x plus 12 squared. That's completely different. That means to square the number 12, which would be 144. It's only the units that are squared, not this at all. So even if you do this, that would be wrong. That means 3x plus 12 times 3x plus 12. The only thing that's squared are the units. So you would need to write units and then square them, or leave them off if they don't give you any units. Does that make sense? You can just put the letter U. You could do U squared. Yep. But again, if they give you specific units like inches or feet or miles, you have to use your correct units. Okay. Here's our information on circles, which we already talked about. So just to clarify, diameter goes through the center. Radius goes from the center to one side of your circle. Circumference is the distance around your circle. Everybody okay with radius, diameter, circumference? And then yeah, that's it. And then your formulas are right here, which we already wrote on the board. The circumference can either be 2 pi r or pi d. So that's right here, pi d or 2 pi r. And the area is pi r squared. Are we good there? Okay. Now here's my rule for pi. In this class, we are not using a calculator unless we get to the homework and we have really crazy numbers, right? And then you're allowed to use your calculator. But on your test, I'm not going to give you crazy numbers, so you shouldn't need a calculator. Pi, we will never approximate pi. What is pi approximately? 3.14. We will not do that unless we have a multiple choice question that says use 3.14 and then they've given you choices. If they do that, you want to use 3.14 so your choices match. Excuse me?
So like pi, we have to like
So here's what we're going to do for pi. No, you couldn't. You'd be writing forever, right? So we will practice both ways. We'll practice leaving it just in terms of pi, not plugging pi in at all, just simplifying our answer. That's more than likely what you'll be asked to do on the test, is just leave it in terms of pi. Or if there's some problems where they ask us to round, then we can practice using our calculator and rounding. But when we use our calculator, we won't use 3.14, we'll use the pi symbol, because then that carries it out further than 3.14. Okay? So don't ever approximate. Either leave it in terms of pi, or grab a calculator and type in the pi button. Don't use 3.14 or about 22/7, okay? Don't do that. Unless it's multiple choice, and then do whatever the directions tell you because you want your answer to match their answer. So for example, find the circumference and area of a circle with a radius of 8. Be careful. Sometimes they trick you and they don't give you the radius. I can't write on it. They don't give you the radius, they give you the diameter. So be careful. If you know the diameter, what do you do to get the radius? Divide by 2 to get your radius, okay? So in this case, we want to find circumference and area. Let's leave it in terms of pi first. Notice your directions say to round your answer to the nearest tenth. On your homework, I want you to follow the directions. Whatever your textbook says, that's what you're supposed to do. So if it says round, you're going to grab a calculator and use the pi button. If you don't have a calculator at home, if you have a cell phone, it turns into a scientific calculator on your calculator thing. If you don't have any access, your Chromebook should have where you can pull up a calculator too. But if you don't have any access, let me know. Okay, so circumference. My formula is either 2 pi r or pi d. What's the radius? 8 centimeters. We're going to practice leaving it in terms of pi right now, so we're going to simplify it but leave pi in our answer. So how could I simplify this? 16 pi. You can go ahead and multiply 2 times 8. You get 16 times pi, and then you should still have centimeters in your answer. You learn your geometry usually in 7th, and then you don't use it again until you get to geometry in high school. Okay, when you get one of my calculators, if you need to use one on the homework because it says round to the nearest tenth, just a reminder that your pi button is under the clear button here. It's in blue. Does everybody see? It's in blue under the clear button. So what that means is you would have to type in 16 times, and then you would do the little blue button, second, and then pi, and then enter. Okay, and the calculator says that it is 50.265482446. So if I'm rounding to the nearest tenth, what would I put? Approximately 50.3 centimeters. Now, I had a professor in college who was super picky, and she would count off if we didn't use the approximate symbols when we rounded if we did equals. I won't be that picky, but it's good that you understand there's a difference. If this is a rounded value and this is exact. Okay, so when I say leave your answers exact, that means in terms of pi, okay? Mrs. Ashton? I have no idea. That means that she does not have a class. That's her PLC. Like this year we're all meeting in PLCs, and so this is her prep time, but instead they have their Algebra 2 PLC. So they're probably in the teacher workroom 267. PLC is not a class. It is the teacher's prep that they're making us meet together with all the other teachers that teach that same course. Yay! You're so welcome. Bye-bye. Okay. We're not done. We're almost done, though. What do I still need to do? Area. Area. And again, be really careful with your directions. So area, we said is pi r squared. The radius, you said, was 8 centimeters. Again, I'm going to tell you you don't have to include the units in your work for me, but the more you do, the more it's going to help you probably in chemistry when you get to some of those problems where your units are kind of crazy. You're going to square the 8 and square the centimeters, so that's going to help you remember that your answer should be centimeters squared. What is 8 squared? 64. You're not squaring the pi, just the radius. So it's 64 pi centimeters squared. It should be, you want to treat pi like you would a variable. You wouldn't say x 64, you would say 64x. So you do the same thing with pi until you actually type it in as a number. Any questions? Okay, on your homework, you're going to follow the directions in your textbook. So if it says to round, you will need a calculator for those questions that say to round. You have about 12 minutes to get started on your homework. And we should be on track now where this is 1415 homework. So it is due when? Wednesday, okay? Thank you so much. And there's One thing on here I want to explain once it's in everybody's hands. Again, you may want to write on there due Wednesday. Yes, so you want to do it tonight if at all possible, because tomorrow you're going to get another assignment, remember. The only reason I'm giving you 2 days is because I know that sometimes you have things that happen that take up most of your night on one night, and maybe you would have more time on the next night. So I'm trying to help you, not have to be away at a late game really late and then do your homework. Okay.